Hello everyone, the title of this work is Towards Robust Video Object Segmentation with Adaptive Object Calibration, and my name is Xiaohao Xu. This work is presented by Huazhong University of Science and Technology and Microsoft Research Asia. This paper tackles the video object segmentation problem in the semi-supervised setting, which aims to segment one or multiple objects in a video sequence given a notated object mass of reference frames. In real-world videos, perturbations commonly exist due to signal noise, camera defocus, and fast motion. Meanwhile, the model robustness becomes critical for real-world applications, especially for some safety-aware applications such as autonomous driving. In the past few years, we have seen a lot of progress in the video object segmentation. However, according to our study, existing advanced VOS models, including CFBI, ALT, and STCM, are fragile to natural perturbations, especially for the scene containing multiple objects. Thus, we propose a robust VOS framework that exhibits superior robustness against perturbations while maintaining high performance. Towards robust VOS, we consider two key factors that matter. The first part is a robust object representation, which is extracted from references for building correlations to the target frame. The second part is a robust mask calibration process to produce pixel-wise classification conditioning on the referenced object representation. For the construction of robust object representation, we introduce an adaptive object proxy representation for referenced objects robustly, which reduces errors incurred by unstable pixel level matching. Here in this figure, the objects proxies are denoted as dots. For our adaptive proxy representation, we observe pixel level embeddings can be inherently categorized into semantic clusters. Traditional pixel level representation is vulnerable to noise, while the object level one loses details. The proposed adaptive object representation can be solved such dilemma by representing an object as a set of semantically similar proxies via clustering-based aggregation. For robust mask decoding, we also calibrate the object masks by updating object representation and masks in an interleaving manner progressively, which achieves discrimination among coexisting objects. Our motivation for this procedure is to incorporate discrepancy between different objects into object representation. Thus, we can reduce the ambiguities between objects. Then we show the experimental results in the following. The comparison between our method and other state-of-the-art methods is shown above. Our model outperforms all the previous SOTA methods even without using any external data. Our method stands out under various evaluation metrics, especially on unseen categories, which demonstrate the great generalization ability of our method. We also show the comparison on Davis. Our model also achieves much better performance, especially on the challenging Davis 17 test step split. Here we show the comparison of average overall performance on YouTube VOS over time. Performance on all the videos are normalized to the same length, and our model has the least performance decay. Here we show the qualitative comparisons on YouTube VOS. Our model can tackle cases such as object occlusion, large camera motion, and the scene with multiple objects better compared to previous competitive methods, STM, STCM, and CFBI. Then we show some qualitative comparisons on the Davis dataset. Our model also can show stronger performance in the cases with multiple objects and object occlusions. Then we show the quantitative comparison on our pilot study on the robustness to perturbation. And we summarize our findings on the right. Firstly, we find that current VUS models are not robust to image perturbations. Secondly, we find that higher performance on clean benchmarks may not guarantee better robustness. Finally, we find that the proposed VUS framework can help improve the robustness. We also show the qualitative comparison on robustness to perturbation. Though our baseline is strong enough to well handle some cases with multiple similar objects on the original clean video datasets, the prediction of our model is more stable and consistent under perturbations. We ablate the main components of our model in the table. Our model shows significantly better performance compared to the baseline model. In conclusion, in this work, we first conduct a pioneer study on the robustness of VUS models, and our pioneer study reveals the fragility of current VUS models under perturbations. Then, towards the robust VUS, we propose a new adaptive object calibration network that can improve the robustness of VUS models. The model includes two components. The first is an adaptive object proxy representation for robust correlation matching. The second part is a discriminative object calibration module for robust mask decoding. Our model achieves state-of-the-art performance on standard VUS benchmarks, while achieves much better robustness on the established VUS robustness benchmark. That's all. Thank you for watching.